Okay, hello, welcome to the Ethical Considerations in 3D Digitization Part 2. So the previous presentation focused on ethics, quite heavily on the ethics of digitization as it affects Indigenous communities and the restitution of culturally significant artifacts. But here we also need to be thinking about how our 3D and the curation of it affects everyone, considering disabilities and how it affects our environment. So Andrea Wallace in 2022 asked, how do we ensure that equity, not just equality, is extended through different iterations of an artwork according to need? So this presentation will cover the topics of accessibility in terms of disability and technological access, as well as the impact that digital heritage can have on our global environment. So digital access to collections offer benefits to many people with mobility disabilities. However, it often remains inaccessible to people with vision, hearing, motor, and cognitive impairments. So the universal access to cultural linguistic heritage is a right guaranteed by the 1948 Universal Declaration of Human Rights. However, there are still many barriers to access, and with each new arising technology that we use, we need to be considering how it will affect access to those with disabilities. So UNESCO has created a set of guidelines for heritage practitioners. So by following certain standards for accessibility and incorporating assistive software and hardware tools into the development phase, digital documentary heritage repositories will allow those with vision, hearing, motor, and cognitive impairments to access and participate in culture. So this list on the left are some examples of digital tools we use within museums and institutions to allow broader access to collections. Beside the access tools are the ways in which they can actually exclude members of society. So image-based collections available online can exclude those with limited or no vision. Spoken narrative limits understanding for those with hearing impairment, and complex websites can often be difficult for those with cognitive impairments to navigate. So based on these examples, we can start thinking about ways to improve digital access. So these guidelines are provided by UNESCO, and although it's not specifically for 3D images, they are a good starting point for making digital heritage more accessible. So first, we should be considering accessibility at every step of a project, but particularly before it begins. This makes projects more efficient and less costly than having to fix issues post hoc. We should be allocating sufficient resources. So resources should be incorporated into the budget, as well as the cost for regular updates for existing projects. We should be involving people with disabilities and/or accessibility experts in the project design. So including experts in the field, disability organizations, and potential users with various types of disabilities. So these groups are often sought out afterwards for user testing, but the impact is much greater when the project follows a more co-creation methodology. And we should be working with experts in subject material. So experts in a given subject can best identify how to describe information in an accessible form. And we can be describing content using simple, understandable language. So think about how text is structured, maybe creating shorter sentences and avoiding technical jargon. And we can design digital platforms with accessibility in mind. So think of layout, menus, buttons, forms, search engines, and navigation. And finally, we should be organizing digital accessibility awareness training for different stakeholders. And there are also some advanced guidelines. So using a text description for digital images or 3D models enables those with visual impairments to use screen reader technology and allows those with learning disabilities to better understand the meaning or relevance of the image. High resolution images enable magnifications without too much pixelation, allowing those with vision impairment to explore the image by zooming in. And videos accompanied by captions should be used for those who cannot hear the audio or who may not be fluent in the language that is presented. It's best to offer a selection of font sizes and appropriate color contrast. Sign language for those with auditory disabilities who have difficulty reading may find sign language easier to follow, and the interpreter's face and movements can offer more nuance and emotion than captions. And audio descriptions for those with visual disabilities can provide additional information about what is visible on screen. So providing content in multiple languages also enables greater outreach. Automatic translation is a cost-effective method to do this, but of course, you still need to verify that these translations are correct. So fortunately, there are projects conducted by researchers who to allow greater access to digital heritage. So one such project is by Rossetti et al., working with a prototype of a square in which the Leaning Tower of Pisa is located. So by 3D printing their 3D reconstruction, they were able to provide both tactile and audio to any piece of information so that a user with visual impairment can explore the 3D model. So the aim was to make the user entirely autonomous in the exploration of the work. And areas of the model that were too small to feel were 3D printed in another scale and placed in the panel separately. And audio was enabled by placing buttons beside each model component. So different shaped buttons provided specific information. Circles were used for practical information, triangles for historical overview, and squares for architectural descriptions. And sensors activate with a welcome audio track when a user approaches the model to explain how to interact with it. And here is another example. This project aims to demonstrate how gamification can be used to increase access to museum collections to visually impaired individuals while respecting cultural values and protocols around heritage. So they acknowledge that that many cultural items, particularly those belonging to Indigenous communities, are used for ceremonies and are not to be touched or played with. Which is an obstacle for those with disabilities that require a tactile experience to interact with the heritage. So they argue gamification of 3D printed models is an ethical solution for this. And this can better provide an inclusive environment for people such as elders from Indigenous communities with reduced vision who want to handle heritage objects. Their case study was at the Winnipeg Art Gallery, where they created gamified models of original artworks with the inclusion of information written in Braille, while asking the questions, which gamified strategies would be beneficial for the blind community, how can this best be implemented, to whom would the resulting digital data belong, and how would such data be ethically operationalized by sponsoring institutions to support blind visitors from historically excluded communities. So shown in this slide are a few examples they created. On top are cave paintings from northern Spain turned into 3D printing puzzles. And below are drawings of Persian stamps, 3D rendered and printed as a tactile stamp. So providing access to those with disabilities is not the only consideration. Also, how the technology itself can limit accessibility to digital heritage for many people. The price of hardware, software, electricity can inhibit access, which can result in the digital divide, which still affects a large portion of the global population. So 3D models comprise a very large data set, including raw files and all associated metadata and paradata, which altogether can often be in the gigabytes. So this is a challenge when trying to abide by the FAIR principles. Large data sets that are fully accessible often not only lead to high storage costs, but can cause issues with broadband if models are not optimized for web viewing. 3D model optimization, which involves reducing geometry and texture size, is a solution for web visualization, and distributing for a broad audience. However, this also means the reduction in model quality. So the question remains how to disseminate the high resolution model. If we provide downloads for the high resolution model, we are requiring users to have specific software, adequate hardware, and some level of expertise. So digital technologies are changing and improving rapidly from hardware, software, operating systems, and file formats. And often, in order to run improved softwares, we also need to upgrade the hardware. Moreover, the way that the public views web-based media has changed. So in 2010, 97% of internet usage took place on desktops, while in 2020, this mode only accounted for 46% of internet usage. So 3D data accessible online will be viewed primarily over web devices, which model optimization, again, needs to be accounted for. So while there are many sources outlining best practices in digitization, such as the London Charter, Europeana, and the ADS, there is still a lack of standardization in the field. For example, a standard in file format. So best practices represent broad ideas, which often translate to vague suggestions for standards. However, Richards Rizzetto in 2022 asked, do we need standards or are guides to best practices sufficient? And this question is asked due to the ethical implications of digitization that we've already touched on. So digital archaeological data is managed by diverse communities, all with their own requirements and needs. So who decides what standards are best? So perhaps the sometimes vague nature of best practice protocols prevent restriction in project execution, especially when it comes to access and dissemination. One element of accessibility that we should be aware of is the digital divide, which refers to disparities in ICT access, usage, and outcomes. So factors that play into these disparities include socio-demographic, socioeconomic, personal elements, type of technology, digital training, and infrastructure. And these gaps can intensify inequalities within and between societies and within the realm of cultural heritage. It can limit the value that it plays in society, such as knowledge development and the sense of identity that we can get from cultural heritage. So climate change is a huge topic, and the digital humanities community is in its relative infancy when learning to deal with our contributions to it. When we think about archaeological excavations, we can name quite a few environmental impacts. So carbon emissions for flying to project sites, the use of plastic to bag artifacts, and the economic impact of continuous field seasons imposed on local communities. But we can also be giving consideration to environmental impacts from digital archaeological projects. So these include manufacturing constantly updated machines, 3D printed filament, physical space, and energy from cloud storage and data silos. So the BRS human rights priorities for the information and communications technology sector outlines the risks of raw material sourcing and forced and bonded labor. Hardware relies on the sourcing of a wide range of minerals from all over the world, which can often be susceptible to human rights violations, including child labor, health and safety, working hours, and remuneration. Contribution of data centers and computing facilities to climate change is substantial. Of course, digital humanities is just a small portion of this. Information communication technology sector contributes 1.8% to 3.9% of global greenhouse gas emissions. In comparison, transport accounts for 14%, which we often utilize in our research. So the Digital Humanities Climate Coalition Toolkit provides suggestions on how to limit our environmental impact. Of course, when digitizing cultural heritage, we use a lot of hardware, computers, cameras, 3D scanners, drones, and 3D printers. Hardware has an embodied carbon cost in addition to its electricity use. So it's best to use them as long as possible and repair them when possible. We can also try to buy secondhand if it's possible and recycle broken beyond repair devices. Data traffic also has a carbon cost. And with the advent of faster speeds with technologies such as mobile 5G, we are downloading ever higher volumes of data to our devices. Mobile internet is inherently more energy intensive technology, but with responsive servers detecting the speed of the connection to offer downloads to match, a computer connected to a wired connection will be offered the highest quality data. Video or streaming data, followed by Wi-Fi broadband, 5G mobile, then 4G, with 3G devices, being offered the smallest data, involving less server-side processing and the lowest carbon footprint. So researchers developed a method known as the green algorithms for calculating the carbon footprint of various computing tasks based on factors such as hardware, runtime, and the location of the data center. This is focused on the processing of the data, but we should also be taking into account some other factors. So the planning stage of the project arguably creates the highest impact. So when choosing the hardware, we can consider the ethical implications of how these resources were extracted. Rare minerals are required to manufacture hardware, and the mining of certain resources is sometimes bound up with exploitation and conflict. Once the data has been obtained and processed, we want to publish and archive our primary data in order to obtain fair data, particularly to enable reuse, which is key in terms of environmental footprint. It may require energy and resources to archive raw data, but it would likely require more to reobtain that data from scratch by another researcher, if that's even possible to reobtain. So basically, you should not be collecting or creating anything without consideration of your responsibility to sustain it. Data can be stored more sustainably by keeping it offline. And if you must transfer large data, you can do so during off-peak times when electricity and broadband demand are low. So, for example, overnight instead of during work hours. And this is a strategy known as carbon-aware computing. So some questions to ask yourself to go forward. Can I offset my electricity use in any way? Am I aware of the environmental costs of producing this hardware? Can I repair it if it's broken? And can I recycle it, if it's beyond repair? So I would like to wrap up with this quote by Pendergast and colleagues. They say that the notion that cultural heritage organizations should digitize collections because of a general perception of value or interest, or should strive to digitize all analog materials, ought to be abandoned. Instead, organizations should aim to digitize specific items when requested by users, or those that are at risk from a preservation perspective, while also working to bolster the collection's discoverability. So since digitizing collections is very commonly done these days, this may seem like a bit of a radical statement. They said this in the context of environmental sustainability, but it can also be thought about in terms of digitizing indigenous material and technological and disability access to collections. So the most ethical form of digitization is actually to slow down and question your reasonings for doing so, and question how this is going to impact the wider community.